Okay. Are y'all coming from the downstairs room?
No. You're this last one. Thank you.
You're welcome. Okay, yeah, we're in the first day of lecture and it feels good. It's been a while since we've had a class this dense, I feel like. Wow, syllabus, so far. I have one left. But that's okay, because I have it on the Discord as well. Okay, so this is certainly going to be designed to be an in-person class. So for the last few years, we've had a hybrid model, we've had online classes, but this is software engineering, and one of the integral parts, one of the important parts about actually getting a good software engineering experience is to be amongst your peers, to be able to delegate and collaborate and cooperate on your code base. So we're going to see what we have in store for us over the course of this semester. This is actually the first time I'm going to be teaching this class. I haven't gotten to the slide where I introduce myself, but I'm Ted, so I'll do that, and then I'll do it again when I get to that point. But since I've had an opportunity to teach this class, I want to do something a little bit different than what I do with my web dev class. So my web dev class is pretty akin towards a project-driven class, much like what software engineering will do. But when we talk about software engineering, we're going to see when we start to kind of crack into what we want to cover over the concept of this class, we want to think bigger than just a 3-person project, like what has traditionally been done in this class. We're going to talk about how we're going to organize our class to try to do that. And so when you're in industry up until where you're at now, a lot of your development has probably been more or less in isolation, right? So it's a lot of solo projects, a lot of individual projects. There are some classes that might let you pair program or maybe even group up into a group of 3. But so much about what the professional environment about software development, you have to elevate, you have to rise from being able to control all of the variables yourself, where you're 100% in charge of the design, the implementation, and the testing, where the entire application lives strictly in your head. When you go out into the professional realm, you're talking about code bases that can be hundreds of thousands. It can be millions of lines of code with dozens to hundreds of developers who are all concurrently working on the same code base. And when you're in that environment, you have to trust other developers to contribute towards the project. Each person has a role. They have a task that they have to do, and you have to work together so that you get an end product that is then delivered and deployed. And so here, what this class should really aim to do is to start to introduce you to the strategies, the approaches, and the tools that facilitate team-based software development. So right now, you should be super proficient at individual software development. So we're going to start examining how the complexities change once we start introducing more and more people into the mix. Okay, so that's kind of like the elevator pitch as to what we've stepped into for the introduction to software engineering. So let's take care of the details that everyone already knows. It's from 3:30 to 4:45, right? It's Tuesdays and Thursdays, and it's in this class, Math 322, which we're pretty packed in. Let's see, what else? We have a Discord server, and that'll be my primary mode of being able to interact when we're not inside this lecture. So we will do in-person lectures twice a week, and outside of that, we'll be able to continue our dialogue. We'll be able to continue our conversation into that space. And you'll see that I've already published the syllabus inside of the resources channel there. And if I haven't flagged you with the role of student yet, send me a message inside that server so I can, because that's how I'll start broadcasting whenever I have information to share. Okay, now let's get we'll move on to the instructor information. Today will be the syllabus day. We'll take it easy as we acclimate from summer. We'll make sure everyone understands exactly what the scope of the class is. And then whenever we're done, we'll call it, whether it takes an hour, 15 minutes or less. Okay, with that said, you can, if you want, follow along or just look at the screen that I have set up. So I'm Ted Holmberg. I am an adjunct professor. I usually teach the web dev class. I've historically taught the intro sequence. I'm also a postdoc research inside of the Gulf Sea Research Center as well. And so I'm super excited to be teaching this class. This is one I've been wanting to teach for a very long time. And it's finally, I feel like we're finally in a position where we can teach it the way it should be taught as well. With that said, I have an office. It's in Math 347. I can't say I'm necessarily there very often. I will schedule to be there Mondays and Thursdays. I'm not allowed to have any office hours before 5 p.m. though, because my current work assignment does not include a teaching assignment, which means I'm not allowed to do instruction duties during my work hours. So this is technically an after hours job, even though it's starting at 3:30 to 4:45. That just means after I'm done this, I have to put in another hour and a half of research to compensate for the instruction we're doing here. But you can also make appointments. So if those times don't work, we can try to find a time that does work. And then you can always reach out to me on Discord. And ideally, we can also have peer-to-peer model where each person can kind of facilitate and help answer everyone else's questions. Because at the end of the day, at the heart of it, that's what software engineering is really all about. Okay, so student information. What do you need to know about yourself before entering into this class? Well, clearly, you should have completed the prereq, which I think is data structures. So that means everyone should be a proficient software developer, which is going to be super important because everyone's going to be participating in the construction of software throughout the course of this semester. You should have strong programming skills now and problem solving skills. If a lot of people have an imposter syndrome, chances are if you made it through the data structures, you do have those skills. You do have that confidence. If you don't, though, you should program more in your off time. That is, so that leads to the second part. One thing that I will say is going to be super important in this class is a very strong work ethic. Because when you're talking about a team-based environment, no one wants to be with anyone who is a weak link. And so we're going to take a different approach in this class where I'm going to try not to make this the passive experience where I sit in front, like I'm doing right now, and talk for 3 hours each week until we hit winter time. So you're going to see we're going to have a lot more peer-to-peer instruction. And the big motivator behind that, I haven't gotten to my objective slide yet, but I'll give you a little bit of foreshadowing. One of the big motivators is that while you're working through a computer science program, by the time you've taken, how many credit hours of computer science classes do you take by the time you graduate? Is it something on the order of like 36 credit hours? Does that sound about right? It's been a while since I went through the bachelor's program, but it's 120 for the whole thing, right? And that includes like the university requirements, that includes the College of Sciences, and that includes the departmental. And I think the department gets something on the order of like 36 or 40 credit hours that they get to claim as part of what you have to take. And then the rest, the university gets to decide, like what general electives you want, what English classes you want, what social sciences and your sciences and whatnot, what math classes you should take. And that's all predicated on like what college you're a part of. That's why if you're in the College of Science, you got to take calculus. If you're in the College of Liberal Arts, you don't. But if you're in the College of Liberal Arts, you have to take more foreign language classes. Well, those are all college requirements. Okay, that's neither here nor there, though. The point is, you take a lot of computer science classes. But when in my role as the industry liaison, when I would talk to a lot of the hiring managers, when I would talk to a lot of the senior level developers, and we would try to figure out how we can try to pipeline a set of students so that they were industry ready. We always got something that was pretty similar. It's that our graduates have very strong technical skills, but they always were looking for us to improve, to find ways of building on what's called the soft skills. And so soft skills are the ability, those abilities to be able to strongly communicate with team members, with other people under different contexts. So like, for instance, if I'm a software developer, I'm going to talk with someone differently if they're a non-technical client versus if they're a technical client, versus if they're a colleague who's a co-developer, versus if it's a manager who's a technical manager, versus if it's an administrative manager. And so how might I think of these contexts? Well, if it's a client, they might care more about the features. What does the application do? If it is a colleague, then they're going to care about what is it I'm implementing and how I'm implementing it. And if it's a non-technical manager, it's why is 40 hours of my time trying to debug worth it in terms of salary? And all these things you have to be able to justify in a way, right? There's different ways to communicate about the same kind of code depending on who your audience is. Being able to identify that and be able to talk at a technical level, being able to talk at a non-technical level and be able to drop in and out of that is a very important skill that we're really going to explore in this class. So I want you to come away not just with being able to work with team-based tools to build a large-scale application using a variety of technologies, but I want you to be able to illustrate that you have strong soft skills while doing so. So that's going to be one of the core drivers, one of my core pillars that we're going to keep in mind when we look at how this course is going to be organized. I don't know how I got there from strong work ethic, though. Took the scenic route. Okay, and then a willingness to participate in teamwork and peer-based collaboration. That's going to be this semester defined, right? So if you're not comfortable sharing your ideas or asking questions or working in groups, this might not be the class you're going to enjoy so much. Okay, so a quick overview then. So this course is designed to provide an introduction to software engineering. We're going to focus on the life cycle methods and tools. So we're going to do this in a couple of different ways. You're going to see that there's going to be 4 different graded components that's going to allow us to kind of examine these various different parts of a software's life cycle. And we'll get to there when we get into what the workload is going to be. But really what we want to do is we're going to emphasize the design, the implementation, and testing of a relatively complex software system, an object-oriented software system. And so we're also going to explore, well, we'll look at the general software development practices, but we'll also explore tooling to be able to facilitate and build out and deploy our application. And so for that reason, we're going to, our IT director, David Pace, is going to be one of our best friends to facilitate our ability to do cool things. Okay, so let's see. Some of the topics that'll be covered are, we're going to talk about what software engineering is. What is the software development lifecycle? How do we contrast software engineering from traditional engineering? How do we contrast software engineering from simply software development? These are all things that we'll cover when we actually start getting into the lectures. And this is all covered in the first chapter of the textbook that we'll see what it is when we get to the end of the syllabus, which I don't know if it's available through the bookstore. I might have to send them an email just to let them know to go ahead and get it. But you should also be able to get that textbook through Amazon or I think O'Reilly. And in fact, I was looking in the old Discord server that Lance ran actually, which I think is, I'll have to check. I think that there's actually a PDF floating around in there as well. So there might be a free copy. Okay, so what else are we going? So what are the other topics? So clearly we're going to talk about software engineering, right? Like that's in the title. That's like the easy give me. We're going to do an analysis of specifications and design that's going to be super critical to go ahead and guide us on what it is we're going to develop and how large or small should the final application be. We'll look at some key principles that go into software design, such as cohesion and coupling. We'll look at the solid principles. It's pretty much just the list of solid principles. I'll just leave it at that now. I could list them all. It'll be confusing without having additional context, and that's not what we're here for today. But one of the key fundamental concepts that have always traditionally been part of software engineering is the solid principle, something that goes back for decades and decades. So it's not a software engineering class unless we cover it. But we'll also explain the value of why we want to adhere to these solid principles. We'll also look at design patterns. Some of these design patterns you might have seen in 2120. Like, did you look at the factory pattern or the singleton pattern or like the strategy pattern or like the MVC pattern? Yeah, so you heard about it. That's good. That sets a foundation. So we'll look deeper into patterns and what it means for refactoring our code base. And then we'll look at different testing methodologies. So I know that you've done a little bit of unit testing inside of Java 2, but you probably don't understand the value of it, because I think you just do it as like a lab assignment. I mean, you might theoretically understand the value of it, but you're going to see the true importance of it when you start working in a team-based environment. And we'll talk more about this again when we get to the slides. But just to kind of give you a little prelude on why unit testing is important, it's important for a number of reasons. The first is to ensure that the code you're creating is correct so that when you do integrate it into your software system, it's not likely to cripple anything and break things down. Second of all, usually when you're broken into teams and you're working on the same software system, you're concurrently all waiting on code from other teams. So one way for you to be able to build out your part of the project, even though it might have dependencies that another team is working on, is to be able to mock out that data and test against it in the form of unit tests. So this allows you to create objects that you pass into your system and see, oh yeah, my system can handle an object if it actually existed. So that's another valuable thing. But this is a thing that the textbooks never really talk about. It allows you as a software developer to have accountability. And I'll talk more about this when we get into unit testing, but effectively, when you are a junior level developer, typically you have a senior level developer, you have a senior or you have your software architect who's going to create the big picture concept of how the system's going to run. And then you're given this small piece. Now, the way that unit testing works in a functional dev environment is your first task is to go write the unit test before you do any implementation on what are the expected function calls, what are the expected method calls, what are the set of inputs that it's expecting, what are the set of outputs, and then you go back to the architect and say, is this correct? And effectively, you are building a contract between you and the architect now. So as a junior developer, you're saying, is this what I'm supposed to implement? Because effectively, if you pass the test, you're done that part of the implementation. And if that architect okays your unit test, then your role then just becomes diminished of passing those tests, building it out so that you get the functionality you need, and then you can move on to the next task. And if for any reason the software system does break down, it's no longer your fault because those tests were okayed by the senior level developer. So it's a way of assigning accountability on whether what's implemented was what was supposed to be implemented. And again, that's one of the big important things about unit tests that never gets mentioned when it's brought up. It's always talk about correctness of code and veracity. But one thing that's also equally important is accountability as a developer amongst other developers. Okay, let's see, what else are we going to talk about? Software configuration management and version control. So right now, I know everyone knows like Git at least this much. They know how to at least like clone and push and pull. And even if you're in a project, a group project, in a lot of other classes, usually the scope of the projects are small enough that you can still kind of like avoid having to use Git in a very serious way. Like even if you're in a team of 3, that's still small enough where you can even like drop that in like a Google Drive or something and just synchronize it that way. And each person has like their own version. And then you just like one day decide to merge it all together. Well, you're going to see, we're going to be working ideally, I think, in a repo that includes everyone in this class. And so then the implications of how we use version control, that actually matters. We'll talk about frameworks as reusable software products, packaging, how to package our code for reusability. And then we'll just look at some of the introduction of software architectures, things like MVC-driven architecture, pipes, filters, different schemes like monolithic architectures versus microservice architectures. Okay, let's move on. Let's talk about what the objectives and the outcomes are for this class. And like I said, it really breaks down into wanting you to develop both technical skills and soft skills. This class is really aimed at trying to accomplish those 2 things over the course of 16 weeks. We'll see how successful we are because this is a big experiment. So I have no idea how successful or how much of a train wreck this might become. We will find out. But ideally, we'll all walk away with these, well, the objectives, we could think of what are the theories, what are the concepts that we're trying to get from this class, and the outcomes are what do we get by implementing those theories and concepts. So in terms of the objectives, we want to ensure that, so every student in here should be able to then understand the software development process, including management, risk, and key factors involved. We're going to bring in stakeholders. You'll see a little bit when we get into the grade factor that'll give us specifications, and then we'll be responsible for delivering applications for our stakeholders. And we're going to learn how to develop and manage use cases and software life cycle models for project development. We'll analyze and resolve design issues in software development. Trust me, this will crop up. And we'll do peer reviews where we can go ahead and look at the design decisions and see how we could have improved it or why something doesn't work. As I stated earlier, we're looking to try to foster and build and improve the communication presentation skills of everyone involved, especially in a technical sense. We'll get a better grasp of how we can use version control and what are the appropriate practices, such as committing, branching, merging, and resolving conflicts. We're going to explore agile and iterative development methodology. So we'll start looking at more or less how to manage the people in the software effectively. So it's not just about optimizing our code. You have to figure out how to optimize the use of people as well. And that's what Agile principles is all about. They'll have an emphasis on being able to learn to read and interpret technical documentation. So in many classes, you're given a textbook that breaks all the concepts down. Ideally, what we're going to explore here during this class is we do have a textbook, but there's going to be a lot of tooling we're going to have to learn. And so a part of this class is going to be where you have to go and read the documentation and go and watch tutorials and go and look at online resources and become a domain expert in a particular tool. And there's a lot of team-based tooling that we're going to need domain experts for. So that's going to be a big part of what we want to try to accomplish during the course of this semester. And then finally, we want to be able to develop this kind of self-learning strategies. How can you go ahead and learn these things in the absence of an instructor who kind of paves a path for you? So what are the expected outcomes? If these are the objectives, if these are our learning objectives, well, then we want to be able to deliver a comprehensive set of requirements and use cases to design our software. We want to be able to implement, test, and refactor our software systems according to best practices, not just based off of a minimal viable product. Although we will always start with minimal viable product, but then we'll seek to go ahead and refactor into something much better. We'll look at the complete full software development lifecycle, including problem analysis, design, implementation, testing, and then refactoring within our team environment. We will present and communicate technical solutions effectively in both a written and oral format. We'll talk more about that because that's going to be one of the 4 pillars of what we're going to do for grades. We will obviously learn how to manage and integrate code with version control systems, which will be super valuable because ideally we're going to use GitHub and we're going to have a lot of activity on this GitHub, and we're going to have some really lovely markdown pages, and we're going to have some good commit histories on there so that when you walk out of this class, you should have hopefully a big repository that you can point and say, I contributed to this. Because that's what you're always looking for. What are the crowning jewels of your portfolio? And the bigger and the more complex the software system that you can go into the architecture of, the better it is for you to try to impress a hiring manager. Obviously, to produce a collaborative project, that's going to be the end goal of this course, but we want to ensure that we're using these Agile methodologies. And then again, we're talking about being able to apply these technical documentation so that we can successfully learn on our own. Because once you get out of the classroom setting, like one of the interesting things about software development, software engineering, is that it is a job where you will never stop learning. So I had a friend years ago who had gone and gotten a degree in accounting. And the things that he learned in terms of what accountants do inside of the university setting have been very representative in what his career trajectory has been. And he's doing the same kind of work day after day after day. And he likes that. He likes the sense of knowing that next year, he's going to be doing the same thing he did 10 years ago when he first learned it in university. That sounds boring to me. I think one of the awesome things about software engineering is that you're constantly learning something new. But it means you're always having to learn something new. I couldn't tell you how often I have to constantly update the content of the web dev class because web technologies go in and out of vogue in months, not years. It's very different than the enterprise landscape, like with a Java, where you have a very stable release cycle. But even then, Java's now on 2 different releases a year. So it just seems to be in vogue right now that languages are constantly adapting and evolving, whether it's Python, whether it's JavaScript, whether it's Java. And so one of the challenges then, as a developer, ideally as a software engineer, is to be able to keep up with the curve and learn the new tools so that you can build your applications in the most efficient and powerful way that's available to you. Okay, so that leads me to the pedagogical approach. How am I actually going to teach this class? Well, like I said, it's my aim not to just sit here and lecture down to you over the entire course of this class. What I really want to try to do is simulate a real-world professional environment that'll give you a sense of what an industry-like experience might be. Now, that's challenging because we're not actually in industry, but we have a lot of developers. So why don't we create effectively a mock startup where we're all in the same company together? Okay, so with that said, the entire class will function as this startup organization. Right now, we'll just call it 4210 startup, but maybe one of the first things we can do is name our startup. Doesn't have to be that. The class will take on clients, stakeholders of my choosing. And I already know I've been in talks with the chair and a number of faculty members who have requests for applications that would make the lives of students, of staff members, of faculty members better on our campus, in our department, in particular, in our department. So we're going to take on the job of taking in these client requests and building solutions for them, just like what you'd have in industry. And we're going to oscillate on, we'll talk more about how we're going to organize this as we move deeper into the class. But the goal is we're going to take on these specific project requirements, and deliver on those requests, which is ideally going to mirror what it would be like if you're in industry and you get a client and a client does request a particular application. You're constantly having to do this pull and push on finding out what it is they need from it, building a minimal viable product, building a portion of it, sampling it out and seeing if it meets their specifications. Okay, so this is where traditionally in the classical software engineering class, we would then say, oh, and then each of you would be divided into like teams of 3 and then work on a project in isolation. But that's where we're going to deviate a little bit. Instead, we're still going to lump into teams of 3. We're going to call those pods, like a pea pod, right? So each pod will have 3 members, and those members will work together because they'll be assigned some tasks that will build out to be part of the larger, broader application of what we have to deliver. But other pods will have to communicate across each other. So you'll have inter-teamwork and intra-teamwork. You'll have the intra-teamwork between the pods themselves, and then the inter-teamwork where pods will have to communicate and provide, effectively be clients and producers to one another. So the idea is we're going to distribute the task of building a very complex application towards various pods so that we can manage and build something big at the end of the semester. Now, I haven't quite defined what it is we're going to build over the course of this semester. I know what it is, and I'll give you a hint when we get to the end of this, to the end of the syllabus. Okay, so this is just mentioning, yeah, the interesting thing about this will be we have this intro, and here I have, just so we can see, I created a visualization. This is an example of 5 pods that have to potentially cross-communicate between each other, and each one has a set of team members inside. We'll talk about how we can grade this in a moment too, but we'll use Agile methodologies. You'll be able to use things like Git commits, and we'll be able to use sprints to see how each individual is contributing to each pod and how much each pod is contributing to the project as a whole. And that's effectively the rubric we'll be using for grading. So even in a project-based class that involves everybody, we can still drill down to the individual to see who was our MVPs, so to speak. Okay, so let's talk about what's actually going to get graded over the course of this semester. And again, these are very lofty goals. So we'll see how much of this I can actually accomplish. So, like I said, I have a vision of 4 different types of projects that we're going to uncover from here to the end of the semester. We have 16 weeks. Every semester is about 16 weeks. That means we have about 32 meetups. And it's not even that, because one of those weeks is like the exam week, and then we get like holidays and things like that. But so our maximum amount of time is going to be 16 weeks. So the first thing that I want everyone to be able to do is to actually present a tech workshop, to give their own type of tech workshop. And this isn't an individual, this is the pod. So remember, we're going to be breaking the class into teams of 3. Each team will be assigned a particular type of tool that facilitates teamwork, team-based implementation. So I'm going to give you the set of tools that will be presented on. Now, traditionally, when I teach these classes, like when I teach web dev, did anyone have me for web dev by chance? It's been a while, I think, since I've taught it. Yeah. So if you haven't, I mean, I posted all of my lectures on the YouTube, so you can check and just see an example of what I'm talking about. But normally what I would do is I would go through the work of building out a workshop where I step through a technology to uncover it for you, where we take a journey together and we start with like the hello world, and then we get to the point of having like a simple REST API, if it was web dev. And so what that does is it provides a very strong foundation for being able to explore technology, but to explore technology in a way where you have to explain it to someone else and walk other people, novice people, through it. And you see, this is something that a lot of people in our field do to sharpen their skills. There's a lot of tech blogs out there. There's a lot of tech authors out there that simply go and spend their time breaking these concepts down. You probably also see it on YouTube. A lot of YouTubers do this as well. And this is the best way to harden your technical skill, to try to break things down so that you can understand the ecosystem well enough where you can then express it to someone else. So the goal here is that each pod will become a subject matter expert on some type of tool that we'll actually be using to build out our applications. And so eventually, like after maybe starting about the 3rd week is what my plan is. So we'll start breaking people into pods next class. It's not, usually you don't want to do it in the first class because you don't know who's going to actually still be in this room when we hit Thursday, or how many more people we're going to have in this room. So usually we want to solidify our groups, at least on the 2nd day. But once we hit to the 2nd day, I want to actually have our pods defined, and I want to assign this project so that in 3 weeks' time, we can start doing these presentations, because it's super important that everyone gets what we're going to call tool certified, so that you learn how to use the ability to, say, for instance, use linters, or you learn how to use Git effectively, or you learn how some of these like Scrum methodologies, using a, say, for instance, like Google Projects, or being able to track issues on Google Issues, or how to do like a merge request. So we're going to go ahead and assign those out, and then each of the pods will have a walkthroughs. Take a long time. It's not like a presentation where you just talk about concepts, right? With a walkthrough, ideally, everyone else is going to have to bring a computer or whatnot. So we'll have to give instructions ahead of time on what people have to do to set up for it. And then you'll have the full hour and 15 minutes to go ahead and walk through a technology. And so by the end of this, how many people do we have here? I had like 30 syllabi that I had printed out, and I gave them all out. So let's say we had 32 people here. Yeah, that gives us a decent number of pods where it probably gives us about 6 weeks of peer-to-peer instruction, where each of you will get a turn to guide the rest of the class through a technology. So if one of the pillars of this class is to actually do a presentation and a walkthrough of a very valuable tool that you're going to be using after you graduate from UNO. Oh, and the second thing then is you're going to be the ongoing technical support for that tool. So if anyone in the class has a question or they forget something, that pod becomes the domain expert, the person, the people to seek out for answers related to that tool. Well, then the next thing is, equally as important, is going to be what we call our tool certification. And this is going to try to capture that concept of where you go to these workshops, or you go through certification processes after you're employed, to learn more and more technologies. So it's not just good enough that each pod does a walkthrough for the class. It's important that the rest of the class completes all those walkthroughs. So there will be submissions on those and those will be just like the classical labs that I would give out of my web dev class. So you'll be graded on the workshop development and presentation, and also the actual ability to finish other people's presentations. Then on top of that, again, I want to examine the entire life cycle. And so it's difficult to have things like legacy code when we have no code base. So what we're going to do is we're going to have another project where we're going to go back deep into your history of like 1583 or 2120, and you're going to have to refactor one of your old assignments to be compliant with what you would consider to be a junior developer professional level application. So you get the experience of seeing all the bad decisions you made and how you might refactor to improve them. But improve them in a way that's scalable and complex, and maybe adds in things like GUI elements or a web client elements or database elements. So say, for instance, if you take the mud game, which was a very basic toy, you might readapt that to be something much deeper realized, because at this point, I would think most of you are seniors at this point, juniors or seniors. So your sophistication level should be that much greater. So the challenge there is, can you take something that you made in the past and actually make it great? And then finally, we have our final project where we all come together to try to build an application with a lot of people. So let's talk about how the breakdown of this is actually going to be for grade purposes. The tech workshop development is going to be 20% of your grade. The tool certification is going to be 20% of your grade. The code refactoring assignment will be 20, and the final project will be double 20. It'll be 40%. So I'm envisioning, and again, I've never taught this class before. These are very lofty goals. I'm hoping we can do all this. But with that said, this is a work in process. So don't be surprised if like grading shifts or things might have to be changed over the course of the semester. This is me giving you an insight of what I want to get out of this class so that you can get the most out of this class. Because when you take a software engineering class, in my mind, it should be the class that prepares you most to go into industry. So I'm trying to optimize what are the things that you should get out of this class as much as possible to make you industry ready. And then based off of time constraints and other limitations, we'll then see how we might have to scale that down. So I'm just letting you know, I'm going to be flexible because I don't have a true understanding of what's reasonable. So we're going to take an agile approach to our instruction. And we're gonna set high goals, but we'll be adjustable. Okay, in terms of student success, well, the grading is going to be done objectively, but I'm going to give you all of the measures. I'm going to give you all the rubrics. You'll know exactly how to be able to determine what your grade will be. There will be no surprises. And it's not my inclination. I don't usually favor written test. I don't feel like that's a good way of evaluating the ability to create and deploy and deliver on software. Okay, that finally brings us to our textbook. So our textbook is going to be the Modern Software Engineering. The first couple of weeks, I'll go and I'll start actually just giving some lectures off of this until we're ready for you to start presenting to the classes as well. So I have, so all the lectures I'm going to give are going to come from this book. And like I said, it's available, I know, on Amazon. I'll talk to the bookstore to find out if this is one that they can get as well. Some recommended books, The Phoenix Project, which is a novel about IT, DevOps, and just helping businesses win. So you can see kind of what the information technology infrastructure is like in order to support a dev team, and also soft skills, the software developer's life manual. which is one of the big key things we want to try to get out of this class. Okay, with that said, just course communication, yeah, Discord. And everyone should have a link to that from the departmental Discord. If you're not on the departmental Discord, you should join that. And then other things, attendance, yeah, you should definitely attend. Class is super important because we're all a team. And so you're gonna understand why you're definitely gonna want to come to class when I share some of the insights about what we're gonna build. Academic integrity, you want to work hard, learn useful skills and knowledges. If you don't work hard and learn things, then you're just wasting your time. If you come out of this class and you put in low effort and you kind of avoid doing the work, you'll get what you put into it. And so then why are you here, right? You're spending a lot of money and a lot of time to come away with very little. And then if for any reason, I don't think that this will be an issue because we're really flexible, but if for any reason there's any issues, please come with me and I can work with anything related to like, well, whatever, like I have an open door. Okay, and it's pretty much that's the syllabus. We did a good step through. It's pretty verbose. It's, I think, 10 pages, but it was my vision of what I want. And I added an illustration that I did in LaTeX. Okay, with that said, I'll give you a small primer of what the application that we're going to deliver is, or at least one of the applications. Like I said, we're going to effectively be the equivalent of something like a DXC, where we're a set of software teams that can potentially take in a rolling set of projects, and then we have to prioritize them, assign them to pods, and then start creating a game plan on how to deliver on them. But one guaranteed one that I know is going to implement our TV display. So everyone's seeing kind of the TVs we have mounted across the department. Yeah, they're kind of boring, right? They're passive. They kind of just show some imagery. They're not very interesting. You come into the computer science department, you want something that's kind of flashy, interactive. Well, that's what we're going to do. We want to try to build interactive kiosks, right? So we have Raspberry Pis and we have these special input devices that we've ordered for this class to be able to work with called Leap Motions, so that they can capture hand gestures. The idea is that we don't have touchscreen monitor TVs, and those are very expensive anyway. And it's cumbersome to try to interact with the TV with like your phone, because then you got to use the QR code, and how many people actually do that? So the more frictionless approach is, what if you could kind of wave your hand in front of the TV and then interact with it? And so instead of just having these very passive displays that are mounted on our wall, we can start building very specific micro applications that can be then housed in this broader application. Things like, what are the tutor hours? How do we get in touch with the student organizations? What are the office hours of the various professors? What are the classes, or where are the classes at? Or what about some fun video games on there? So think of all the different types of things that you could perceive utilizing a more interactive form of these TV displays. And that's going to be one of the driving things we're going to try to build out. We have, I want to say 5 Raspberry Pis, and we have 5 of these Leap Motions. So the Leap Motions are, I mean, they're actual hardware. So to test this, you have to be on campus. This is something you can't do remotely, right? Like you can't test the Leap Motion without having a Leap Motion. So if you want to work on it remotely, you just have to buy one and actually just like have it at your house. I think they're about $200 or so. So probably better to try to figure out and again, we have limited resources. That's on purpose. We have way more people than we have developers for, but not everyone has to work on the Leap Motion part. That's the idea. You can work on maybe the database part, or you can create a server client part where you can use like mouse and mouse input to at least mock what you can do with the Leap motion so that you can still build a part of the application, and the other team that's actually working on Leap motion integration can then integrate that into your mouse-based implementation. This starts to give you an idea of how we can start bringing teams to work even when you have limited resources, so we can build out something that's super grand. And what would be awesome is if we can think of a vast variety of different use cases using the Leap motion and these Raspberry Pis, so we can create a very, very kind of a large amount of applications that then are supported by the end of the semester. And then we would actually deploy those onto our department. So then after you graduate, after you take this class, we'll still use that software so that as we do these tours for prospective students, you're going to be the ones who had built the things they'll be interfacing with. And now this is only the first class where we're doing this. In future classes, I definitely will then have legacy code that I can then have them do bug fixes on, and updates and upgrades, right? So we're going to create, you are in a special position where you're going to create the basis for what's going to be an evolving platform for years to come. Well, yeah, that's perfect. That'll make for a great class next time. And then they'll definitely be cursing your name. No, yeah, but you might even have those same curses though to other team members. They might deliver code to you. No comments. And so what's really interesting is we'll talk about, like, we don't have anything really set in stone. I'm really flexible about the technologies we can use. We're using Raspberry Pis. It might be easier to use like a Python, for instance. But that gives you kind of like a primer of where we're going to go. Is there any questions? I've talked for, what is this? Oh, almost the entire time.
So these little micro cameras or something.
Yeah, that's exactly what they are. So the Leap motion has two different use cases. They have a use case to make like a touchless kiosk where you could, like, say, for instance, mount it above the TV, and it's kind of like a Connect for your hands, where it's like a high resolution dual camera system that can capture the depth and then track and then map your digits and your gestures. And so ideally, probably what we would want to do is maybe make a driver so we can easily, seamlessly use that inside of our application. But you know what? One of the pods is going to be responsible for doing a workshop on the Leap motion. So it's not something that I'm going to define so much on how to use. I want one of your teams to do that. But yeah, and the other use case, I said there were two use cases. One of it is to make like this touchless kiosk. The other is to mount in reverse on head-mounted displays or augmented reality displays, so that when you put your hands in front, you can actually capture your hand motion without having to wear gloves or use any kinds of wands or controllers. Yeah, so there, in fact, check Leap Motion's GitHub. And this is one of those beautiful things where I want you to explore and see what you can find. Because that's one of the things that you'll have to learn. That's a skill set you're going to want to have acquired when you go into industry. Because let me say, it's way better to learn all these things here when the threshold of failing is very low. Like, the stakes are low here, right? Like, this is a safe environment where your like salary isn't contingent on being successful. So you can kind of like skill up as much as possible so that when you go into industry, you feel very comfortable and confident when your team members or when your manager asks you to do something, you're like, well, what's that technology even mean? Or how do I use that? You're at least familiar with it, and that puts you a leg up. You might not be a master, but you'll at least have the understanding of it. Any other questions? It's super important to make a GUI. Everyone's made a GUI before, right? Well, we'll definitely have one of the pods go into GUI making and all of the considerations and roles and responsibilities. Might be easy to do like a browser-based one or one inside of, or like I said, we can do something in Python as well. There's a lot of options out there. Browser-based GUIs might be easy for that. We're not, so that's a great question. There's actually ways of styling that you would need a minimal amount of CSS. CSS would help, but maybe you can use the CSS framework where you just learn how to use the framework and it really does all the heavy lifting of the styling. Like something like Bootstrap, for instance, where you just apply some class names and all of a sudden you have this beautifully responsive website and you didn't really have to do any of the actual implementation. And that's what tools are supposed to do for us, right? It's supposed to allow us to rapidly create applications without having to do all of the implementation work, right? And so we want to learn how to do that. We want to learn how to use other people's tools so that we can focus on the problem at hand, a cool interactive OS that we can then put all sorts of applications that support you who are current students, that support prospective students, that support the Java help desk, that support our student leaders, that support the faculty members, right? That you bring up, yeah. So we're going to learn more about how. So to give you a quick rundown, we'll actually have lectures on how to be able to organize that. Typically, what we'll have is a big board that we're going to have a set of tasks on, and the task can traverse different stages. So like open tasks, tasks that are currently in progress, tasks that are complete and done. Just for the bear set. And so from here, each pod would then have the liberty, the option to take whatever task they want from this board and claim ownership on it. And once they take that task, now they become responsible for delivering that task. And so collectively, and so we're going to rotate this between pods. Each pod's at one point throughout the semester going to play the role of a scrum master, which is going to be to support all the other pods and to make sure that they're feeling like they're making progress. And if they're not making progress, they'll try to help them in whatever way they can. But when we go to assign these tasks, we have to collectively decide how hard a task is. Not all tasks are of equal weight, right? Some are much more difficult. So we would give those more points so that they would get, a team would have more time to work on the more difficult task. Whereas if it's like a simpler task, those would be worth a lot less points. And so, yeah, so teams, ideally, will know what tasks we need to accomplish to build out our application. The teams will select which ones they want, and then you make progress on it. And that's why I was saying I can track, even though this is going to be a very large scale project, we can track by each pod based off of the task they select. And then from the task, we can look at the commit history to see the participation of each of the group members. So it gives you a good insight exactly on where the code base is coming from. Well, keep in mind, our deployed environment is Raspberry Pis. So we should just well, you don't have to attach it to a Raspberry Pi, but you should expect that your target platform is going to be able to run on a Raspberry Pi. Because the idea is that the leap motion needs to be physically connected to the device that it controls. And so these TVs, I mean, Raspberry Pis are cheap, right? They're like under $100. So we ordered enough Raspberry Pis to actually bolt onto each of these TVs and then actually hardwire the leap motion onto them. Now, you don't have to develop your software on a Raspberry Pi, but you do know that has to be your target. This is going to be your target of deployment. Oh, for sure. But I mean, you could probably just like develop inside of a Windows environment. And as long as you understand that your Raspberry Pi is running some kind of like Linux distro. It's as long as you're not like using your GPU for whatever reason, right? Like the Raspberry Pi is not gonna have a GPU. So if your application requires like CUDA processing, then that's not gonna work. But that's one of those things that you have to consider. These are the project requirements. But you can have a developer platform, and then you have your production platform. But yeah, these are all good questions, and it kind of gives you insight on what it takes to even start thinking about what it's going to mean to build something out. And again, all of our actual requirements are going to come from the faculty members, which I haven't formally even gotten. I just kind of broadly know, but we really discussed some of the cool things we can do that would be nice to have just think about what you would want to do with this and how it might support what you want from the department. Okay, any other questions? That will be the leap motion is going to be the big project. Now, yeah, but you bring in an interesting point, because we're going to take in multiple projects, and it's going to be up to us as a team to decide which of the projects are the most important to deliver and which ones we are allowed to let fall to the wayside. Because let's say that we get a request from Dr. Suma for this other thing, but like the leap motion one is the big one. If it comes to having to decide we do this one or that one, we have to decide what is the one that we'd rather go. What is the one with the biggest stakes attached to it? Which is the one that we're actually going to be able to deliver in the time frame that's allotted to us. And we only have 16 weeks. This isn't a lot of time, but I'm not expecting us to have, it would be awesome if we get a fully constructed, well-built application. But guess what? If we don't, that's awesome too, because then I get to give the next class a half-broken application. They have to figure out how it works and how to make it work. You're like, it's not broken. It's just stubbed out right now. Any other questions? Okay, so I guess before I let everyone go, let me ask you a question then. What was your expectation coming into this class? And like in terms of what you want to get out of it and what the workload was likely to be for a software engineering class. And I'm kind of just interested to hear what the student perspective is going in blindly on a class from, I don't know, either the description or by the name or. Oh, well, I'm hoping that this class should certainly do that. So yeah, if you're looking for good resume classes, the ones that I think are really good for that, anyone that's a project-driven class. So like this one, web dev, mobile apps, you always come away with a project that you can then show off and even deploy. And you can use as a basis. So even if you're not super satisfied with what you got at the end of the semester, there's no reason why you can't take and use that as the foundation and make it into something that is a crowning jewel for your portfolio. And the more classes that are project driven and the more diverse you can get these like really large scale kind of complex applications, the greater that's going to make your portfolio look. And when you go and talk to one of these hiring managers, like you want to, it's kind of, you want to be in a position to try to control the narrative, right? Like you try to take the storytelling away from them. So either they can give you arbitrary problems like, oh, solve this like binary search tree on this whiteboard, because they need to give you some kind of task, or you can try to lay down that you built this really interesting application. Hey, it's on GitHub, and try to encourage them to open it up. And then suddenly you're controlling the flow of a technical portion of the interview where you're talking about all the design strategies and the problems you had for something that you've pre-thought out of. So that's one of the great things about these portfolio pieces is you try to leverage it during the interview process so you can kind of control the narrative on who's speaking about what. Any other questions? Well, if there's no other questions, there's no reason to hold you any longer. It's 4:37. almost filled the time just with the syllabus though, and just making sure everyone understand. I think it's important that everyone understands the context of a class before we really start with the lectures. So you know what you're walking into. Anyway, I will see you all on Thursday, and Thursday we'll actually assign pods, and I'll actually assign the tool, because I want people to start working on their presentation ASAP, because we need to learn the tool so we can start building applications.
Do we have a choice on which pods we like?
Yes.
Okay.
So, oh, I should have mentioned that. Everyone join the Discord. Don't forget, join the Discord and start. If you don't join a pod by yourself, I will assign you. So if you have preferences, do it now.
How are you?
There, doing pretty
Had a
good.
good summer?
Busy.
I know.
I can't believe that we've already started.
I know. So quick. Well, I'll see you on Thursday.
Yeah, I'm excited about the semester though.
Yeah.
Should be fun.
Oh, sorry.
I was trying to enroll on 5210.
You should be
instead of-
able to, right?
They are not allowing. I just made the Datsuma, and he is way helping me on that one. So let me see what will happen. If not, 4210 will also be.
Yeah, it was awesome. You can get credit for
Yeah,
it.
but that's fine. Like I'll get another opportunity to get one more classes from my master.
That's true.
Hi, I'm Peter, and I'm an exchange student here.
Oh, excellent.
Yeah, from Germany.
Oh, that's cool. I'm actually working with, so with my research, I'm doing some river modeling, and one of my research partners is in Austria.
Oh,
So
okay.
7 hours,
Interesting.
so we're on
Yeah.
7 hour differences.
Yeah. It's quite big. Well, actually, not exactly. I'm a visiting student just for one semester. I got a Fulbright scholarship. I think that tells you anything.
Oh, awesome. That's great.
Yeah. So I was just wondering about the requirement with the what did you call it? This mud game thing,
The,
Uh,
wait.
where we have to get some old project.
Oh,
first.
well, so I'll leave it to you to find a derelict project that's worth working on.
Okay.
But if you don't have a derelict project, I can request from one of the professors some other student's bad code that I can hand off to you.
Oh, okay.
But, or I'll let you just design a project if you want. So
Okay.
I'll be, like I said, I'm gonna be relatively lax this semester, because this is the first semester that I'm teaching the class. So I'm still trying to feel out what works and what doesn't work.
Yeah.
But really, what I want to get out of that is, so one of the big things is, as you probably could tell, most of the students are from the department.
Yeah.
And so I think there's something interesting about reflecting back when you were first coding and you made those poor design choices, and then you're forced to look and say, how can I improve that? But not just that, the other part of the process I want to do is each person's going to show off the refactored code that they did, and then we can kind of talk about it. We can do what's called effectively like a stand-up, where you can talk about like your design, what your design strategies and how you decide to implement it, and get feedback on how you might have improved it, or like how clever your ideas were.
Yeah.
So that's, so just having a project allows you to still contribute in that way.
Well, it's just a bit difficult because in Germany, university is very theoretical,
Mhm.
and we don't have that many projects. So those I just worked on them on my own completely, and they all involve machine learning stuff.
Well, that would be
So
really cool. I mean, probably a little bit more complex than a traditional, like, basic equivalent of like a print set of if else while loop kinds of projects. But I mean,
I definitely have some
so probably,
graph search or whatever else, and I don't know. Really.
well, do you have one that you worked on before you felt more confident and comfortable? So I'm assuming there's a series of these projects. So you didn't just work on one, you probably started working on.
Maybe we just have different definitions of what a project is. So when I'm just having some homework assignments, it's not really a project for me.
Right.
It's something which I worked for a longer period of time, right? So something which I don't really have. Except for this very, very big ones.
Right. Well, we'll figure, when we get
You'll
there,
figure it out.
we'll figure it out. We'll figure it out. Like, what's the, what's the middlest size project that you have? So it's,
Okay, I will have to look into that.
yeah,
I
like,
don't remember.
do an postmortem on your like legacy of code and just give me a rundown of what's there.
Okay,
Because right now we're kind of talking about it in a very abstract notion. I'd be interested in just kind of knowing,
Yeah.
knowing what it is, what it actually isn't.
yeah,
And so
alright.
we can work around that then.
okay. I will try to look into that.
But I think another big advantage of this is just for as many students to be exposed at all the other different things that everyone's building. And the trick's gonna be finding how to be able to get everyone to show things off in the time frame that we have.
Yeah, okay, alright. Thank you then, and
course.
have a good day.
You too.